Now, let me just introduce all of our speakers, and as we hand it off, we'll make sure we flow right along. But our first presentation on the design, evaluation, and optimization of the future in a digital environment is by Harlan Broom, Angel Velez, and Pete Thompson from Autodesk. That's going to be followed by a presentation from Maria Korshund from SAS Alarm on the future alarm and dispatch systems, trends and needs. And that will finally be followed by the last presentation of the day, the presentation that will be standing between you and dinner. And that will be by Brigitte Messerschmidt from NFPA, and it will be addressing fire safety in a data-driven world. So with that, I'd like to turn it over, and if we're able to get our first speakers going, recognizing that we are trying to finish within this next hour, and our speakers are in the cloud, if you will, and joining us from wherever they are. Okay, are you ready?
Okay, can you hear me now?
We can hear you now. Take it away.
Excellent. I see my screen's up. Great. So we're going to run through, three of us are going to cover the content here from BIM, from Autodesk side. And with that, I'm going to hand over to Harlan Broom, who's the Revit product manager. Hey, Harlan.
Hey, thanks everybody. It's great to be here virtually with all of you, and I hope this is interesting. So Pete, next slide. So today we're going to break this down really into 4 sections. We're going to talk about design, talk a little bit about building information modeling, how the growth of BIM is changing things in the design world. We'll talk about evaluation and how you can actually leverage building information modeling for analysis. We'll talk about optimization. How do you repeat that analysis to create better designs and better optioneering, and how do you leverage that for the future? And then we'll talk about the future and next-gen opportunities. So starting with design, I'll talk a little bit here about what is BIM. Some of you may be familiar with the concept of what is BIM, what is building information modeling in general. This is kind of our, standard definition of what this is all about. The important thing that I want to call your attention to here is really that it's a process. It's not simply the act of creating a model. It is a process of actually collaboration and building insights into the built environment, so that you can actually efficiently plan, design, construct, and then eventually manage the entire building and infrastructure projects. So, it's not just a fancy name for we're going to create a 3D model. It's actually all about the information and the process that goes into, things like understanding collisions and coordination between different projects. Next slide, Pete. So this is a graph. It's a couple of years old now, and it we wanted to show this to give you an understanding of kind of the public perception of where things are with the current use of building information modeling in the industry. I think this is like 3 or 4 maybe years old now, and some of the numbers have changed, but it was a prediction based on current adoption. The lowest bar in these studies, like in the UK, 46% had adopted, and then their predictions on how fast they would grow adoption. In particular, in the UK, things have changed a little bit recently. They're saying that adoption has slowed, and they're looking at why some of that has happened. But these trends have been, seen kind of across the world, no matter where they are, and we continue to see a lot of uptick in this. And one of the biggest drivers here is around mandates. In particular, like in the UK, there's been mandates that have driven for all public projects. They're going to use BIM and different levels of maturity of BIM as they try to strive to become more and more digital and more aware of the level of detail and the level of collaboration they're providing on projects. Next slide, Pete. And again, though, it's not about just creating drawings, which is kind of the thing that everybody has to still do today, but it's actually really about the importance of the data. and the ability to actually understand everything there is about the elements inside that model, being able to schedule the information, being able to actually parse it in a way that's not just looking at a model or drawings, actually diving in and really getting a deep understanding of how things are going to be built based on the actual data that's available within the project. And we see this, kind of the converse of the typical drawing-based method of doing this. Why people are really going to BIM is the amount of information that they gather from the projects that they have, and really what I like to call the ability for them to practice. They build the building virtually, they get all this great information, they can make better design decisions and have better collaboration with all the different stakeholders on the project to efficiently deliver a successful building that's hopefully on time and under budget and all the things that are important in this industry. And next slide. So now let's talk a little bit about why we're seeing more and more use of kind of general analysis with these models. You create these great models, you have documentation, you have the data, but we're finding there's a lot of opportunity in the space for analysis as well. Next. All right. So one of the things that we've introduced in Revit in particular in our latest release is what we call Path of Travel. And this is really a simulation tool designed so that someone very simply can choose a point A or to a point B in their model and understand how the person would move along that path. It's designed to take the shortest path between those 2 points. Because we're using this in a model-based workflow, we understand that there's obstacles, there's doors in the way, there's furniture perhaps that you need to be able to navigate around, and we can actually take that all into consideration and really quickly create that path. It allows for simple analysis of like height zones. So if you need to be able to go through a threshold or underneath a stair, you can understand that. And because it's all based on building information model and data that's here, Pete, there's something on your screen. Sorry. You can actually schedule this information as well. So you can understand the length of these paths. You can understand the time it takes based on an average walking speed to be able to move between those 2 points in the model. You can add additional parameters and information to do calculations or to really understand, how people move. And you can do things like instantly color coding these paths based on that information. So if something's over a specific distance, or if you're looking to make sure you understand how fast people can get out, you can all do that graphically in the view as well, but it's all based on the data. Next slide, Pete. So this is a little video showing this in motion right now in Revit 2020. Basically 2D, like I said, it's pretty simple. We added a button called Path of Travel. You pick the 2 points, it routes the person along the path. And it gives you the ability to customize things like obstacles and the analysis. It gives you the ability to update these paths. If there are design changes along the way, someone moves a wall, you need to understand, well, actually, why I'm not going through this stair in this example, where you can actually see, like, okay, I want to make sure that my head clearance is correct and that I'm not being, someone could actually walk underneath that. And it's analyzing, that route between those 2 points in a dynamic and kind of up-to-date way. And this is just showing some of the filtering capability that we have, the ability to kind of change the line weight, change the graphical standard, because it's obviously important in a lot of these cases, to do kind of simple analysis just on that 2D plan. And here's showing the kind of update workflow, making design changes dynamically inside the model, adding walls, adding doors, and then updating that path, to reflect those design changes. Next slide, Pete. So just wanted to give you guys another highlight of what that's capable of doing. Pretty quickly, you can evaluate these distances and the times in the model across multiple spaces, multiple parts of the model to multiple exits, and create these kind of diagrams based on the model geometry itself. Next slide, Pete. So
leading on from Harlan's great grounding and introduction, and going a little bit more into some of the aspects of analysis that can be launched from the BIM platform. So, for example, one of the teams I'm involved with is the Insight Energy Analysis, which allows the user to look at the thermal properties of the spaces and then do their heat and ventilation, air conditioning analysis and their energy performance model. It uses spaces and material properties, and much of that could potentially also be used for fire safety analysis as well. And that's really one of the optimization pathways, which we're allowing people to optimize the energy performance of their building with cloud services. Additionally, you can also do structural analysis launched from the BIM platform as well, looking at the wireframe analysis of the structural interrelationships of the model, and allows you to size your beams and your columns, etc., through various plastic and elastic deformation processes. And again, there's these properties could potentially be used for structural analysis in fire safety areas too. And also at the moment, it's important to realize that different fire safety engineering related software packages are starting to leverage the BIM platform. So I've got some screenshots here from Pathfinder and Building Exodus as well, where they've imported the IFC model, which Angel will talk to shortly. And also there are elements like add-ins or direct plugins to Revit, which you can use to directly drive the functionality of the BIM model within the package itself by customizing it. So with that, Angel, I'm going to pass over to you.
Right. Thanks, Pete. So I'm just going to talk about IFCs a little bit. So as Pete mentioned, many BIM-based programs, such as Revit, have API that allow third parties to directly access native data for further processing. This allows for a great deal of openness and access to the data, but requires creating and maintaining one-to-one connections between programs, which can be prohibitively expensive, especially for smaller vendors. In 1994, 25 years ago, Autodesk, in conjunction with an industry consortium of 12 initial companies, formed the Industry Alliance for Interoperability, which later became the International Alliance for Interoperability, and finally became BuildingSmart, for the purpose of making a neutral, open format for the exchange of BIM data across products. This became the Industry Foundation Classes, or IFC, file format, which you can kind of see there in the second row on the left-hand side. Now, a valid IFC file has two important components defining it: a file schema and a model view definition, or an MVD. If you've ever heard the terms IFC 2x3 or IFC 4, these refer to the schema, which represents kind of the collection of entities that define the possible extent of representable IFC data. To narrow this down, the MVD specifies a subset of the schema that corresponds to the actual user workflow. The image on the right represents some of the workflows that IFC was traditionally designed to access and address. Next slide, please. So over time, though, IFCs and their corresponding MVDs have expanded to reach adjacent industries. So the top 5 MVDs above all represent, for either IFC 2x3 or IFC 4, some of the traditional areas where IFC has had the greatest impact. Furthermore, there's active work going on in the infrastructure domain for both kind of IFC 4.x and IFC 5, including IFC MVDs for roads, bridges, and tunnels, among other similar things. Of more interest to this group, however, is the recently proposed MVD that would cover fire safety engineering, and that's the one at the bottom. Because this is still in the early stages, there is still an opportunity for all of you to get involved in fine-tuning the workflow behind this MVD, and to also encourage software vendors that create the products that you use to implement it once it has been finalized. So with that, I'll pass that back to Pete.
Thanks, Angel. So we're seeing the process of fire safety engineering world starting to utilize the BIM models more directly. So that process starts with the digital building model in the BIM package. Some of the occupant movement simulation packages are starting to leverage IFC files, and there are one or two with add-ins to BIM packages. And then you can start to visualize people flows or distributions of temperatures within the spaces using BIM platforms' own built-in visualization tools. So what you see on the right, there's an analysis visual framework. So if you choose to, you can put this data back on the BIM model itself directly and visualize the results. Taking this process and integrating it with the BIM model preserves the golden thread of information, which is the term, where we try and maintain consistency of data, iterative checks as the design changes, and also future enhancements as well. So utilizing the IFC files, you can use your model view definition, which is this version of the IFC, to check your model, store relevant data. It could be used for airports, high-rise stadia, etc., etc. You can export the model, analyze your results, and import the results back onto the BIM model. And that's an important process to involve the whole design team, so there's a consistent set of data on the way through, really through the design, construction, and operation phases. So leading on from there and looking at optimization pathways, I'm not going to spend too long on this, but there is application programmable interfaces, you call it API, which Revit has. So you have the Revit main software, has a layer here called the API, and third-party developers can develop their own individual analysis applications to plug into that data and functionality. And you can add your own button on the toolbar to host your own little customized version of the package and analyze, quantify, and use that data. This short video is a quick demonstration of the use of the API. So someone's using the path of travel function here. They've written a custom script using the open source Dynamo package. Allows you to create customized scripts to call inbuilt features. And here the user is choosing 2 exits and automating the running of the path of travel script, really to find, so this is the second exit being chosen, and then they're really trying to find the most remote point from those 2 doorways, and it scans all the spaces in the building, it finds the most remote point, and then uses the path of travel analysis to plot the route out, and it highlights it in red if it exceeds the maximum travel distance available. And then you can tag that, it automatically dimensions it like a dimension line, both in terms of distance and walking time, using average walking speed. And then you can also take a look at the visual programming language behind it. So if people don't want to get deep into the scripted code, you can actually look at this visual programming language, which allows you to build up the blocks of logic to start commanding the BIM package. And this is an increasingly popular way of accessing the sort of digital design and the BIM package itself. And just a couple of notes at the end. I also am a visiting lecturer at University of Lund, and we've had a couple of master's projects which have looked at using the BIM data for fire safety engineering analysis. So Sylvia wrote her own scripting tool to bring the data from Revit into PyroSim, and then on again from PyroSim into FDS. Some of the material data was missing in that data transport process, which she fixed with a side script, and got very good results in terms of looking at the compartment fire modeling, and it worked. It was quite successful. In addition, Christiana looked at looking at evacuation analysis using Simulex, again using the built-in export from Revit, and then also using a new model for movement, which he developed as well to test out, and ultimately running some test situations of people going through a unit test and checking the results for a young population, an elderly population, and checking those against real-world experiments and seeing how the data stacks up. And the flow rates are really quite comparable, which is encouraging so far. And we'll be publishing this work over the next 7 or 8 months. And just finally, looking at the overall future direction for Revit, really, because it's a great data platform for team working and analysis, we're looking to implement very high degrees of accuracy and detail going forward, really to make sure that data is then optimized by enabling lots of analysis, simulations, and iterations of the process, and then also allowing multidisciplinary teams to connect to a cloud-hosted central model, and then allow the design to iterate through all phases of the project lifecycle as the design team connects and shares data on a pretty much a live basis. So you end up with, right from stage one, the design starts, to using the BIM 360 sharing of the model, so that even the construction teams on site, when they go out with their kind of rugged tablets on site, they'll look at the latest design as they build the model. And that's everything.
And Autodesk speakers, perhaps you heard that thunderous applause, so that was great. And thank you very much for keeping us on time. And if you could stay on, we'll have questions at the end, if that's okay. So now we'd like to welcome our next speaker, Maria Korshund, with SAS Alarm. And you'll be telling us about the future alarm and dispatch, the trends, and where we're going with all that, trends and needs.
Yes.
Maria.
Thank you very much. Thank you. And hello, everyone. It's great to be here. It's fantastic to be here. My name is Maria Korshund, and I am CEO of SOS Alarm. That is the national company of Sweden for security and safety. Our vision is clear, and it is to create a safer and more secure Sweden for everyone in Sweden. We are 1,200 people, and we operate in 15 emergency centers throughout Sweden. We handle over 3 million emergency calls per year. And our busiest time is when all of you are off. During Christmas, during New Year's, during holidays, when you have weekend, and when you are on Friday night. When you're off, then we are tremendously busy. I'm going to tell you a few things about that, because it is hard, it is difficult to imagine that when you don't work with it every day. And we operate 24 hours a day, all days of the year. We are never off, we never close, because our business is about being ready and on all the time. If you think about exactly this time but a year ago, do you remember what happened? A hot and intensive May started our summer. Then it became midsummer, and it hailed, so everybody thought, yes. Because when the hot weather and the dry weather got really bad, the pressure on emergency number got really high. So we thought the hail and the rain is going to actually solve our issue. But the day after it was hot again, and the intensive fires really started, and they got really bad the second week of July. I don't know if any of you remember that or not, but I remember that. Because when that happened, all of us who worked with it actually went on total readiness, state of readiness. The Swedes who might not know what state of readiness is, stabsläge. So the whole summer for us was stabsläge. Just a few data on that. If a normal day, we receive 9,000 emergency calls. On a New Year's Eve, normally we receive about 13,000 to 14,000. Not really double, but just about. The summer that passed, when we were in state of readiness the whole time, a few days of a week, they were at that level. It was heavy, it was tough, it was a lot of work, but I think Swedes did a really good job. All of us did. Everybody did a good job. We worked together because we had one primary goal. The ones who were in emergency needed to get help here and now, and it was extremely important. So we did our best to do that, and we did a good job. So thanks to everyone. It went really well. And back to when you're off, everything happens. Things happen in our society. A lot of things happen in our society. We have fires in buildings, and we have traffic problems, we have boat accidents, we have water floods, power outages, crisis, violence, terror attacks, heart failure, and strokes, and much, much more. These are everything that are happening in our society. And when they do happen in our society, what is the most important thing? The people who are on need get support as quickly and as fast as possible. The summer story that I told you is one of those. It happened, and then we all focused on that. Through a wide range of services, SOS Alarm contribute to a safer and more secure Sweden for everyone. This is our core business. We have a wide range of services, and actually what our services together with us do is people who are on need in different scenarios. These are different scenarios that I'm presenting for you that make sure that they get the support and the help as quickly as possible. Our operators, who are on call all the time, 24/7, what they do really when emergency calls come is through listening to the person who is in emergency need, through listening to the person, try to understand what is it that really happened, where did it happen, and to make sure that the right help is coordinated at the right time to make sure that the person in need gets help as quickly as possible. Is innovation needed for security and safety? That we are talking about security and safety. And I'm willing to say security and safety is the area that's expanding quite vastly and a lot. And because of that, innovation is extremely important for that. But to give a view of innovation a little bit, I have to back up a little bit and go to some years ago, where actually the means of alerting or sending alarms was by church bells. It was a lot of years ago, but there were church bells. And that's the way that we could tell people that we are in need and there is emergency, here we come. And then after a while, the church bells ended up being fire systems. And they ended up later on becoming sirens. None of us remember that. Now maybe we're starting to remember that. Telegraphs, do you remember that? And even telephones, when they came, then it was innovation in every word. So yes, I think safety and security has gone through innovation all the time. And are we going to prioritize that going forward? Of course we are. We live in a society that has a lot of challenges. A society where it is an aging society. Healthcare is really good in our society. We get older. And we have babies, and we get more people in the world, and different nationalities in the world. So we have to understand the different languages and all of that. So yes, we have a society that puts a lot of demands and challenges on us. At the same time, this society gives us a lot of opportunity with technology that gives us opportunity to build the next innovation and the next innovation. So innovation are important. Do we work with innovation? Of course we do. We work with universities and we work with research projects in Sweden and outside of Sweden. We take behavior, put it together with technology, and then create the next dispatch system. Actually, that's the way it works. In security and safety, you can never take behavior and people away from technology. They go hand in hand. That's my world. That I think is so extremely interesting. And we, of course, have hackathons, and we work with it, and we get ideas, and we develop our ideas. Now, taking us to the next time move of our innovation And you guys, all of you guys know that. The major part of the emergency calls that come to SOS Alarm come through mobile phones. Of course they do. 85% are mobile phones calls that we receive. I'm going to tell you a challenge about it, but I have a few slides before that. Mobile phones are important. They know a lot about us. They know where we are and what we do and our behavior. We have an app that our customers love to use. And what this app really does, gives the opportunity to our customers, fire rescues, and other customers that they needed, to understand where in our society, there's a map, and the map of Sweden, where in our society in Sweden, events are happening, accidents, fire, climate issues, and all of that. So you can see that in the area that you want, and then follow. How is it going? How is the upgrade going? And that's real time. Extremely interesting. We are developing another app, which is useful for you and I, everyday citizen, to actually, through that app, we haven't launched it yet, we're still developing it, to know what is happening in my vicinity, in my app, that I should know about, and because of that, take corrective actions. All of a sudden, we take it from a general map to my vicinity, and to understand how do I take corrective actions because of that, or in order to solve that. And yet another one that's important, social media. Do we think that alarms can come through social media? I think they're going to happen in the future. Yes. How long does it take? I think it's going to go step by step. How many of you have Alexa, Siri, or Cortana at home? Probably you do. Yes, me too. Are they great? Can you see the next step of that? Can you see that these devices actually can translate real time to different languages? You know, one of the challenges that SOS Alarm has, we translate about 200 languages. Can we get help from some of these devices to translate real time for us? I think that's going to happen. Images and devices, extremely important. Right now, it is through hearing, the sense of hearing, that gives us our information. It is a difficult job to be an operator at SOS Alarm. It really is. You have to be extremely good at reading situations and by through only hearing. Just imagine if you could see, if you could stream, if you could see videos on that. So much information we can get. Do we do parts of that? Yes, partly, but mainly for disabled people that can't do that. So we have some of that, and we are developing that. Or we're going to take it to the next step, to have it for a broader group of people. Looking at it as well, there are some challenges connected to it. So opportunities are mind-boggling, and they're great. Sensors, are they interesting? Just imagine if a sensor in a building which is in fire or might be on fire could actually send an alarm to a SOS Alarm saying, this building is going to cut on fire. Is it going to happen? Why not? The technology is there, really. Just imagine another thing. A sensor in body, maybe in a pacemaker, that could detect a heart failure, and before the heart failure happens, actually to send an alarm. Are we thinking about that? Of course we are. Of course we are thinking about that, because these are part of the next generation dispatcher system. Of course we are thinking about that. Maybe a sensor in a car can actually alarm the system and say that there has been an accident. Is there the application on that? Yes, there is. I'm going to come back to that. Our mission is right help, right place, right time. Now, the opportunities that I mentioned, aren't they interesting, all of them? What is the main challenge to that? Maybe the technology is there, we know that. But what about laws, regulation, and rules? Positioning is one of the main important and a prerequisite in everything that we do. Position you correctly, exactly when you call. How many of you think that when you call SOS Alarm through your mobile phone, we can position you exactly where you are? Okay. Hands up. You know, technically we can, no issue, but legislation-wise, we can't. Why? I think it's because integrity rules and laws that hinder us to do that. There are more legislation issues and rules like that, but this is one of them. Advanced mobile location is one of these. We really want the Swedish authorities to interpret it as it's okay. Finns do that, but Swedes don't. So we really like that, and we want to position you, because a lot of the opportunities that I mentioned to you require exact positioning. And that's one of the issues that's extremely important. Yes, we are working on it. Another thing that we did actually change the law, because we convinced our politicians to do that, is for public warnings. Viktig meddelande till allmänheten, VMA. In English, public warnings. Actually, what happens, before, about a couple of years ago, when the law wasn't changed, SOS Alarm is the one who gives public warnings, actually. We initiate it, and we send it. Before, we sent it to, we were allowed only to send it to the mobile phones that were registered in that area. Evacuate this area, there is fire there, you need to evacuate that now, like that. You know, a lot of people who were registered, they were in New York or some other place, and all of a sudden they got a message, evacuate, there is fire there, and there wasn't fire there, of course, because we sent it to the people who were registered the mobiles in that area, but they weren't there. And that was a law that we needed to change. We changed that. We convinced our politicians to change that. Wasn't it great? And because of that, since about a year and a half ago, we are actually able to send viktig meddelande till allmänheten or public warning to the ones who are actually in that area to evacuate. And there is even next step on that. I see that you're watching your clock. I have a few more slides. I can imagine that Björn is looking at me as well. A car, yeah. Is your car able to send an alarm when something happens and an emergency happens? Yes, if you have a car that has that function in it. Because since about a year ago, there is a law to have that function in the car. So if you have those cars, yes, your car then automatically sends an alarm. There is a sensor in the car who does that. And even there is another option. If the driver wants to push it manually, can do that as well. So yes, sensors are working. But the one that you may not know is, do we have that for motorcycles? We don't really yet, but we are testing it, because we think it's important, even for motorcycles, to have that. A driver who's driving and something happens, an accident, then the driver's phone can send, because we are just testing the application, alarm to our operator, who immediately called the driver back to see if something happens. If the driver doesn't answer, of course, corrective actions taken. And I'm going to go fast. This is one of our crown jewels, situational awareness. We monitor globally, 24/7, all the time, and nationally, to see, can something happen in the world or in Sweden? It might be fire, it might be climate issues, it might be terror attacks, it might be a lot of other issues which may impact Sweden when it comes to security and safety. It's monitoring all the time, and we create situational awareness, and we always share that with us, with the different companies and authorities that are connected to that, in order to have the same information to make clever decisions always. And we've done that during this summer that we have behind us. We did that and published it for everyone 4 times a day. And this is one of the areas that we put a lot of focus on that, because we think preventing safety and security issues are as important as actually working with that as they happen. Artificial intelligence, extremely important. We are working with artificial intelligence, especially connected to medical decision support that we have, a system that we have. Just imagine, through a system, easily to understand a lot faster than a person can understand. If there is a heart failure going on, when the one who's in danger calls in and wants to talk, are they possible? Yes, they are. And we are looking at them. So these are some of the trends. Why not a drone that we can send in to a building which is in fire to understand what's going on, to give us information? Why sending people? Why not drones? Now, I'll save the best for the last. Sweden is one of the countries that has a long history of having one emergency numbers for all of the emergency issues that can happen. Not all of the countries do have that. Some countries do have that. But Sweden is one of the countries who has a long history of that. And we believe, truly, honestly believe, that that's the reason that we have a coherent alarm management system that gives us the ability to focus the person who's in danger and in emergency issue and make sure that she or he gets support as fast and effectively as possible. Yes, people are the most important that we have. The rest is technology, but people are the most important. Now, I have a clip for you, which is only 20 seconds. I like to show it for you, because right now there is a TV series going on Channel 5 on Mondays that actually shows our emergency centers on open TV. Our operators, dispatchers, the way they work, they cry after each call, they laugh after each call, because it's really close to our heart. Now, one that you're going to see in 20 seconds, what he's doing is all of our dispatchers at SOS Alarm like to do in their career as fast as possible. He gives birth to a baby through helping a pair who are in the car, and the baby is born in the car. So giving a birth to a baby over the phone. You're not going to see the whole part because it takes time. You're going to see only 20 seconds of it. And the reason that you're going to see only 20 seconds of it, to see how people are important, because it touches your heart.
SOS 112, vad har inträffat?
Då sitter en bil på väg mot förlossningen och vi kommer inte hinna fram.
Ambulanserna är på väg, så vi ska komma så fort vi kan. Hur mår hon nu, din fru?
Hon är redo att förlösas, jag tror.
Förlossningen?
Ja.
Vad är det, barnet som kom ut där?
Ja, nu är bebisen född.
Han andas och skriker sig normal ut.
Ja, jag tycker jag.
SOS Sverige, premiär ikväll klockan 9.
We actually, all of our operators love to do this because they love to be one of the first one that they get their SOS baby. And they are called SOS baby. So thanks a lot. People are everything, and technology is only enabler.
Thank you, Maria. And
Thank you.
You'll be around for questions at the end. Yes. Okay, so we'd like to turn it over to Brigitta Messerschmidt, who's going to be addressing fire safety in a data-driven world. Brigitta.
Thank you very much, Casey. I know I'm the one who stands between you and a great party and drinks, so I'll try and speak as fast as possible, but I promise you I'm worth it. So anyway, as we've already heard in the previous presentations, there are so much data out there just waiting for us to grab it and use it in order to really get more information that we can use to make our world a more fire-safe world. So that's what I'm going to talk about here, how I see this, fire safety in a data-driven world, and the work we are doing at NFPA in order to promote more fire safety through data work. There we go. All right. I've got to make sure I can see my slides so I know where I am. So the way I've split this up is I'm talking about the data that I see in the pre-fire, during fire, and post-fire. And this is in no way a non-exhaustive list. Oh, it is a non-exhaustive. Oh, I got that one messed all up. But this is what came up in my little quirky mind when I was thinking about this presentation, and also based on the work that we are doing at NFPA. So first of all, of course, is the pre-fire. What information do we have pre-fire that can help us? All about the building. I mean, we just had this great presentation about what BIM can do for us in fire safety, and we really need to take more advantage of that in the fire safety and make sure that we can really get that information on the buildings in order to make better decisions. The other one is inspections. There's a lot of inspections going on of our buildings, whether it's for the active fire protection system or passive systems, etc. So much data are created out there. And then social media. We have a lot of information. The last presenter was just talking about that as well. There's so much going on social media that actually will be able to tell us, is a significant event going to happen or not? And we are not looking at that at all. Going on during the fire, we have the firefighter response, everything, how many fire trucks, how long did it take them to arrive, all that information. But again, following on from the previous presenter, sensor data. We've got so many sensors around the buildings now, and especially in smart buildings, but also our little mobile phones, our Nest thermostats, our smoke alarms, etc. All that can provide us a lot of information, and I'll get back to that and talk about smart firefighting. And then post-fire, of course, the incident data. What happened during the fire? Well, what was ignition? How did the fire spread, etc. And if we are lucky enough, we can get some detailed fire investigations, and it talked about it's very important for us to have those in order to learn from the fires. But another area that really is not really considered is the environmental data. So Margaret was talking about that as well, but we actually have a lot of environmental data sensors around our countries, in cities, etc. An example, we had a big fire in Copenhagen some years ago in a sports center. Whole roof burned off, and it created quite a bit of smoke. 4 kilometers on the town hall square, the environmental sensors that are there in order to measure the pollution from the traffic, etc., spiked extremely that day and said, oh, it was really, really bad air quality. But nobody really was thinking about connecting that to the fire incident, but it was totally connected. We could learn so much from that. So as you can see, I've put some of these in bold, and those that I've put in bold are those that I believe they're really the ones that has to be there. The other ones are the ones that I would love for us to see more. So why is it that we need data? Why is it that we need data for fire safety? Well, first of all, for regulation and code. In order for us to move away from design by disaster, where we just learn from one incident and we change one thing in the code, if we want to move away from that to much more performance-based design, we need to have much more information about what has happened in fires, what our building made of, what is happening around the world. And that is totally linked to risk assessment. We need data to make better risk assessments. Otherwise, we cannot do the true performance-based designs. But then, smart firefighting. Why are we not using all this information to make the life for our first responders easier? So that they, on top of all their great experience, can actually make data-driven decisions. And last but not least, this one that popped up in my mind is smart evacuation. And I think both the presentation we just heard and also the presentation on BIM showed really how you can have this information about the building, the layout, etc., and try to get information where are people in the building, use sensors, use cameras in order to direct people in the right way. Why are we not doing that yet? So what are we doing then at NFPA to try and move all these great ideas forward? So I'm going to talk about some of the projects that we have. It's not everything that we're doing in our department, but those that are mostly related to the issues that I just talked about. So in research at NFPA, we are a great team. One of them is the Fire Protection Research Foundation, headed up by Casey. We also have our data and analytics group, which is a bunch of very creative geeks. And I use geek as a compliment because I think those are the people that truly bring the world forward. And then we have applied research, where we're trying to take the information that we learn from the data people and the information from the research foundation, combining it with global research to actually create some insights on what's going on in the fire problem. So first up, talking about what data products we have related to the pre-fire data. One of them is the ITM data collection and analytics. So ITM is inspection, testing, and maintenance. So as I said before, we have a lot of that going on out there, whether it's inspection of fire pumps, whether it's inspection of fire doors, the buildings, etc. We have all that information, and we're not really using it for much. And if we had that information, if we really collected it and pooled it together and made it possible for us to do some analytics on it, we would be able to help a lot of our stakeholders, and it would help us make better risk assessment, really better do the performance-based options in the codes for not just testing every so and so often, but testing when it's needed. So it's really something that we are working on. It's quite an exciting project. And the next slide, I'm not going to go into detail with it, just to show what happens in our team when we take the great project managers of our research foundation and combine it with our creative data geeks. This is their project plan that they came up with. You gotta love it. So moving on, another really interesting project that we're working on is related to building survivability in the wildland-urban interface. We just heard this earlier presentation about the wildfires in Sweden. As you know, we have a wee bit of a problem in the US as well. And we have some of our wonderful creative data analytics people looking at using information from satellite imagery, environmental information, and some information from building inspections and property inspections to try and predict which buildings would actually survive in case of a fire in this neighborhood. And they have used this on some of the wildfire areas, the wildfires we've seen in California, and they have reached at this point an 85% predictability accuracy in their predictability. So this is quite an exciting thing for us. We continue working on it to improve the accuracy. And even though this is developed based on California data and California experience, this is definitely a general methodology that we can see be applied globally to help us inform us around what can happen in case of a wildfire in a specific area. I cannot talk about data without talking about our risk assessment tool. So again here, pre-fire data, pre-fire information. We made this risk assessment tool last year for high-rise building with combustible facades, where we are using all kinds of information about the building to predict, will this building actually be at risk for fire? What is the risk assessment we have there? And even though, funny enough, talking here about data, we did not have enough data to make it quantitative. We had to make it a qualitative risk assessment at this point. But more details about that if any of you are coming to Interflam. And then, what happens during the fire? What kind of data? And here I'm going to talk just a wee bit about one of Casey's favorite projects, one of his babies, smart firefighting. There's an awesome report that was published by NIST and the Fire Protection Research Foundation on a roadmap for smart firefighting. And it really shows how we can take all that information, data, and technology to help the firefighters make information-based decisions and not just rely on their experience. And that's where, just imagine that presentation we saw first about BIM, that the firefighter would show up, would have all this information about the building, would have the information from social media about people that are in the building, and then at the same time would have access to real-time fire modeling. So based on the sensors in the building, we know that the fire is going on there and there. We can then predict what's going to happen next before it happens. There are researchers around the world that are really working on trying to do this real-time modeling in order to help firefighters on this. We're not there yet, but we will get there. And it's a really exciting area in my view. And then, of course, what happens after the fire when we collect the data? And we can complain a lot about the fire data that we have in the US, but based on my experience, having worked around the world, we actually have the best fire data in the world. We have the best data system coming from the National Fire Incident Reporting System. So we are using that at NFPA to write all these reports about the US fire problem. We're really analyzing it in detail. And we will continue to do that. And right now we're working on modernizing our workflow on that in order to really make even better and more timely reporting on what's going on out there. But one of the things that are challenging us around these data on fires is actually getting data and getting them quickly. So the last project I would like to bring up is our National Fire Data System, which is a system that have been created in order for us to better quicker get data from the fire service, and actually a system that makes it possible to provide data in so many different formats, bring them together, and then for us to do analytics on them. And what's exciting about this is that that's not just for us to use. That has such a global potential, looking at so many different countries, so many different regions that are looking to collect data from fires. So this is really a good platform for that. So anyone who would like to discuss that, I would like to talk to you about that. At this point in the US, we are getting data in very quickly from about 1,500 fire departments, and that's growing. I bet that number has gone up since I wrote this presentation. So it provides us really in-depth access to a lot of the detailed data from the fires. I promised you I was going to talk fast, right? So going forward, what do we need in order to really get this fire safety in a data-driven world? Well, we really need to standardize. First of all, the inspection, testing, and maintenance data needs to be standardized in order for us to be able to compare. But also the incident data. Having talked to a lot of people around the world, we don't even define a fire death the same way. We had a question earlier about how many people die in fires. Well, it's sorry to say, a little bit apples and bananas between countries, because some people define it as you died in a fire, another one's within 24 hours, another one within a year. So you cannot compare from country to country, sometimes even from region to region in some countries. Another thing that we really need to move forward on, and you mentioned that as well, is the use of artificial intelligence and other things that are there, image recognition, etc., in order to automate much more the input data. Right now, we are relying so much on our fire departments and other people out there that are so active in the field and have so many other responsibilities. We now expect them to go home and fill out a 20-page report about the fire in order for us to have information. We need to find a way to make that easier. We need to really get data in. And what if we could have, all those things that are already available, Alexa, Siri, etc., help us on this in the future? Then BIM, that is really an area where we in the fire safety field need to work more. We need to be into that discussion. I was so happy to see it in the presentation earlier that they're already incorporating a lot of fire engineering in that. But we need to talk even more with those people. We need to get even more information in there about what is it that we want to know about the materials and the building, etc. And then how to use it better for whether it's for the modeling or it's for the evacuation, for the fire service, etc. So much more cooperation with that is definitely needed. And I'm happy to see it happening here in Sweden, but I don't see it in so many other places though. And then utilize the data from non-fire sensors and other sources. We are not doing that at all yet, and we need to do that much, much more. So imagine if we could have Alexa and Siri telling us, giving us information when things are happening. And then, of course, social media. There is some interesting work going on at Northeastern University at the moment in Boston, where they're looking at if they could use social media postings, try to harvest those to find areas that are high risk for a fire event. So we should be able to do that much more to get a much better picture of where do we have areas of high risk, and therefore where do we need to focus our attention. So this was my high-level helicopter view of fire safety in a data-driven world, and that was all I have for you.
Great. Thank you, Brigitte. If you could stay up, we do have a few minutes for questions. If there's questions from the audience, and do we have the Autodesk trifecta somewhere on the line as well?
I'm still here, Casey.
Okay, excellent. Thank you. And so do we have questions from the audience? Yes. Bjorn.
I have a question for Maria. You were saying that SOS Alarm is introducing video calls. Is that going to happen? That's very interesting, I think. You know, when you call a doctor, these web doctors, you also send them a small piece of a video so they can see if you're ill or not. So is that going to happen in SOS as well?
What we are looking at is for disabled people, we are looking at it, because we need to have it for if you're not able to talk. So you need to have it. So for disabled people, we are looking at it. We are looking at developing it, yes. But we haven't taken it. We haven't launched it yet, but we are looking at it because not everybody can talk. Because of that, we are doing that. But we want to see the possibilities after that, taking it in a broader sense. We haven't come there. So we're going to start with the disabled, and then after that, we're going to look at it.
Okay, and Margaret back here, and if you could use the microphone, thank you.
Hi, very interesting presentations. I actually have a question for both Pete and Birgitta about BIM. And I think, there's been a lot of discussions for quite some time about the fact that the fire safety community needs to more actively embrace BIM. What's the barrier? What's the problem? Why aren't we doing that better?
Do you want to start, Pete?
Okay, sure. I would say there's probably been two historical barriers. One is that the fire safety engineering courses have been a little slow in picking up the teaching of BIM and introduction of BIM to the students. So, as students go through and learn their fire safety engineering skills through the universities, it's only this year we started teaching that in the universities. So a little slow, but starting now. And then also probably allied with that is up until recently, there really has been not much available for the fire safety engineer directly to analyze for fire safety engineering directly from BIM. And with the new tools becoming available, and also like the path of travel stuff we showed, but also the increased use of the IFC files, the common format to be imported by PyroSim, Pathfinder, and other packages, we are definitely starting to see the early stages of adoption, and fire safety engineering is behind the curve in terms of architectural, MEP, and structural analysis, which are significantly further ahead in the adoption process because there's more tools available.
I think it's right related to the question I asked you, related to the sustainability community and the fire community. And it's all about us in the fire safety community getting out of our comfort zone. We really have a tendency to preach to the choir and confirm to each other, oh, it's so important that we do this, but we really have to go out and talk to people who are working in those other fields. And I think that's been a little bit of the barrier, and myself is guilty of that as well, as you admitted as well. So we got to take it upon us that we need to do more.
Okay, great, thank you. And we'll take one or two more. Francine?
Hi, I was just wondering, Maria and Birgitta, do you have barriers or limitations with gathering data and using the data based on privacy rules and laws? Because it seems like that could be hindering the collection and use of the data that you need.
We have to, of course, consider that. Now that we are getting the information, the data from directly from the fire service, we have to clean that up and make sure that any any information that can be directly related to a specific person is cleaned out, such as social security numbers, any names, and so on that can be specific, identifying a person. So yes, we are very aware of that side of it. Yeah.
Yes, we do. And that's why I mentioned that rules and regulations are the ones that's setting actually the hinders, not so much the technical ability, because those we can handle. But there are laws, rules, regulations that hinder some of the developments, yes. But especially connected to the integrity regulations, yes.
Okay, we can take one more. If somebody has a question, we'll come right up here to Anna.
Well, maybe it's more a comment than a question, but I'm thinking you are mentioning definition of fire fatalities at a different between countries, and it's the same with different terms. So terminology is very important. So I don't know if you have any thoughts. It's both for the rescue service and for the data collection, also for the BIM that you are. Have you any thoughts of terminology problems that you are sure that you are using? A standardized set of terminology that is clear for everyone using the data.
Well, I guess that calls for a standard on standard on data, right? Doesn't it? I think that is a general problem that we have. Yes, we do have some standards that are trying to make sure that we use the same terminology, but yet we're still not there. So I don't really have an answer for you, other than it's something that we have to continue working on. I don't know if you, Casey, have a comment. You look like you did.
It clearly is one of our challenges. I will sort of come back to AI and some of the activities, and Peter and his team talked about their APIs, which help to translate. But some of this is accelerating and helping us to avoid or move with those challenges. So I personally am very optimistic that as we struggle to come up with those definitions and do it the old-fashioned way, we're discovering new ways that are opening doors for us, and it's exciting. So we are at the final moment here, so I think we want to wrap up. I just want to say as we close, this is an exciting session in the sense that we have our three sets of speakers, Peter and your team being one of those sets, and our other two speakers here on stage, that this is just a nice blend of talking about all these great things that are in buildings, and BIM and all this other rich information, and then Maria, taking this and really delivering it to reality, and then Birgitta, putting that in context as we try to move forward with all this. So I think it's been a great session. I just want to say thank you to all the speakers as we wrap up and adjourn for the day. So thank you.
Nice meeting you. Thank you very much.